It's been more than 10 days since a devastating earthquake hit southeast Turkey and Syria. In both countries, the death toll has exceeded 42,000, and a pessimistic forecast suggests that it may reach 100,000. The last issue examined many of the reasons for the devastating effects of the earthquake. Today, we'll take a closer look at the importance of earthquake-resistant design. Designing against earthquakes, earthquake resistance, seismic, and seismic control designs. 11 years ago, the Great East Japan earthquake in 2011 off the coast of Miyagi Prefecture, Japan, recorded a whopping magnitude of 9.0. 15,899 people died, and 121,992 buildings collapsed in this earthquake. Unfortunately, tsunamis, massive waves, caused most of the casualties, and most damaged structures deteriorated. Because Japan had reinforced its earthquake-resistant designs and had experienced numerous large earthquakes, the damage was remarkably small. Buildings are strong against vertical forces, which push from top to bottom, but weak against horizontal forces pushing from the side. The earthquake-resistant design is to construct buildings to prevent the building from completely collapsing when the ground shakes from an earthquake. In other words, it installs reinforcements such as earthquake-resistant ferroconcrete walls, concrete walls added to the building columns to make them stronger, so that the buildings do not collapse even in strong horizontal shakes. There are two main ways to prepare against earthquakes: seismic design and seismic control design. The seismic design uses the principle of wave energy. The shorter the period, the time it takes for a pendulum to travel once and return, of wave energy, the greater the force. So the method lengthens the period of the seismic wave, which is wave energy, to mitigate its impact. Taipei 101, a skyscraper in Taiwan, has a giant pendulum at the top of the building so that it causes the building to move in the opposite direction from the direction that the building shakes in the event of an earthquake. This is a seismic design that weakens the seismic waves. On the other hand, seismic control design changes the natural frequency, the frequency at which it vibrates on its own without any external force. For example, tuned liquid dampers, TLD, also known as dampers, use inertial force, the force that an object tries to stay in motion, in physics. For example, synchronous liquid dampers, also known as dampers, use the inertial force of physics to keep objects in motion. A giant water tank can be installed on a building's roof to absorb seismic waves by using the massive sloshing of water, wave energy of water. Or a huge spring can be installed in both directions of the bottom of a building to prevent seismic waves from being fully transmitted to the building. However, as of June 2022, Korea only has 15.3% of the buildings all over the country designed earthquake-resistant. The rate still remains in the 10% range. With the most recent earthquake in Turkey, we should be more concerned with and informed about earthquake-resistant design.